Hello and welcome to Geometry, Arcs and Chords of Circles. In this video we will solve problems involving the relationship between arcs and chords and radii that are perpendicular to chords. Here are the standards that we're going to be covering in this video, and these are from the Florida's Best Standards for Mathematics. Let's go ahead and jump right into our first theorem. So with our first theorem, we have two chords here. And our first theorem says that arc AB will be congruent to arc CD if and only if AB is congruent to CD. So if AB and CD are congruent, then these arcs are also congruent. And then the same thing goes for if the arcs are congruent, then these chords are also going to be congruent. So it goes both ways. So looking at this first circle here, we have two chords that are equal, which means that both of these arcs will be congruent as well. So if this arc is x degrees, then this one is also x degrees. And then I know that there are 360 degrees in a circle. So I can write this as 64 plus 2x equals 360. And then when I go ahead and solve that out, I would do 360 minus 64 and then divide it by 2, and that gives me 148 for both of these. And then if I need to go back and add all three of these arcs up, then I can. And now looking at our next one, it's telling us that these two arcs are congruent. That means that these two segments will also be congruent. So we've got 2x plus 4 equals 18. I would subtract 4 on both sides and I get 2x is equal to 14. And x equals 7. So I would be able to find x from here. Okay, and then on this last one, we don't have any congruency marks, but they're telling us that AB is 9 and AC is 9. So both of these chords are congruent, which means both of these arcs are congruent. And if this is x degrees, this would also be x degrees. And then I would do 360 equals 2x plus 90. Subtract by 90 and divide by 2. And I get 135 for both of these. And then I can always go back and add all three of these up to see if it works out. For these down here, they're telling us that circle M and circle P are congruent. And then they're telling us that this arc is congruent and this arc is congruent. Well, that would be the same as drawing one of those arcs on one of these sides, or on the same circle. And so it's safe for us to assume that these would both be the same measure. If the circles are the same size, it would be like drawing both of these chords on the same circle. And if they both have the same arc, then they both have the same chord. And so from here, we've got 2x plus 24 equals 6x. I can subtract 2x from both sides. I get 24 equals 4x, and that gives me x equals 6. And so I would be able to find out what x is from there. And then the same thing going on with these two. It's telling me that circle V and circle W are congruent. And it looks like these arcs aren't the same. But if this arc is 162, that means the other part of this, or this major arc on this side, needs to add up to 360. That makes this one 198. And now from here, I've got 198 on this side. That means that this side would be 162. And so that shows me that these two chords, see how this chord is closest to the 162 and this chord is closest to the 162? That means both of these chords are going to be congruent because they both have congruent arc marks. And so I can go ahead and say 9x minus 78 equals 3x. Subtract a 9x on both sides, I get 78 equals negative 6x, and then divide both sides by negative 6, and I get x equals 13. And then if they asked me what zy was, all I would have to do is do 3 and then times that 13 would give me 39. And so that chord would be 39, and then this chord would be 39 as well. Now let's go ahead and jump into our next theorem. Our next theorem says that if we have a diameter or radius that is cutting through a chord and it's perpendicular, then ST, so arc ST, is going to be congruent to arc SR, and then arc TQ is going to be congruent to arc QR, and it bisects that chord here. So looking at this first example, we have BE is equal to 32. So that means that our diameter piece is going to be 32. So our radius would be 16. And they're asking what AE is. AE would also be 16. And then they tell us that we have a chord here that is perpendicular. That means that this piece is going to be congruent to this piece. And it tells us that CF is 11, which makes FD or DF also 11. So CD is going to be 11 plus 11, which is 22. On this bottom example, they give us an arc measure. So SR, which is minor arc SR, so don't forget that it's not going this way, it's going to go this way. So they tell us that SR is 100 degrees, so I'm just going to put that out here. And then if we have this radius perpendicular to this chord, that means this piece is congruent to this piece, which means this arc is going to be congruent to this arc. And if both of these arcs add up to 100, that means that RQ is going to be 50, and then QS is also going to be 50, and then they add up to make that 100 for RQS. For the last theorem that we're going to look at for arcs and chords, it says if AB is congruent to CD, so if both of my chords are congruent, then EF and EG, which are these two perpendicular segments here, are also going to be congruent. And then it also goes the other way. If these two pieces are congruent, then I know that those chords are also congruent if they're perpendicular like this. All right, and so with this first circle, they don't give us any congruency markings, but they do tell us that this is 6 and this is also 6, which means ST is going to be congruent to UV. And if TS is 4x and UV is 28, that means that we have 4x is equal to 28. Divide both sides by 4, and I get x is equal to 7. And then don't forget, if this is perpendicular to that chord, we have a radius that is perpendicular to the chord, so we've kind of already been looking at something that looks like this. That means that these pieces are also going to be congruent based on what we already know. And so if we know that UV is 28, that means this piece is 14 and this piece is 14. This piece is 14 and this piece is 14. So UZ is going to be 14. And then UR, notice that we have a little right triangle here now. And when we create that little triangle, and so this is how your circle problems get more and more complicated and they kind of add on to each other. So I've got R, Z, and U, and if this is 6 and UZ was 14, I could use the Pythagorean theorem to figure out what UR is. So we've got 6 squared plus 14 squared equals UR squared. And when I complete my Pythagorean theorem, I end up getting 15.23 and some change, and so UR would be 15.2. Okay, and then looking at our next one, they're telling us that CB and CD are congruent, GQ is equal to 5x plus 3, and EQ is also going to be congruent, and that's going to be 3x plus 18. So I know that these two pieces have to be congruent because those chords are congruent and perpendicular to the center. And so we've got 5x plus 3 equals 3x plus 18. I'm going to move 3x to the other side and I end up getting 2x plus 3 equals 18. Move 3 to the other side, so I'm going to subtract 3 from both sides and I get 2x is equal to 15. Divide both sides by 2 and I get 7.5. So x is going to be 7.5. And then if they asked us to go back and plug in for EQ, we have 3 times that 7.5 plus 18, and that gives me 40.5. And that's our video covering arcs and chords.